Welcome to Creative World. In this video, we will solve Chapter 2 exercise problem number 2.24. While solving this problem, we will be using Kirchoff's voltage law. This law states that sum of supplied and dropped voltage across circuit elements inside a closed loop is always equal to 0. According to this law, a cumulative voltage inside a closed loop is always equal to 0. Sum of all supplied voltage is always equal to sum of all drop voltage. Now move towards the problem. Exercise problem number 2.24. Find voltage VAD in given below figure. This is the circuit diagram of given problem. We have to find the voltage between these 2 points A and D labeled as VAD, and this label VAD is indicating that A would be on higher potential than D. So without wasting time, let's proceed towards the solution. If we observe inside this circuit, the only information that is provided is in the form of voltage. No other circuit element's parameter is specified. So we will use Kirchoff's voltage law to solve this problem that is purely based on voltage. Before starting the solution of this problem, first we have to identify the direction of current inside this closed loop circuit. We will assume the direction of current is clockwise, and we are interested to calculate voltage between these 2 points. A is on higher potential and D is on lower potential. Voltage between these points is labeled as VAD. Now we will apply Kirchoff's voltage law inside this half closed loop. We will start from this side. Current entering terminal is negative, so voltage across this resistive element will be taken with minus sign, minus 3 volt. Move to the next element. Current entering terminal is negative because of clockwise direction of current. So the voltage across this voltage source will be taken with minus sign. Move to the next point. Current entering terminal is positive, so voltage between these 2 points VAD will be taken with positive sign. Now we have written the Kirchoff's voltage law equation for this voltage VAD. The equation is minus 3 volt minus 4 volt plus VAD is equal to 0. Inside this equation we only have one variable, that is VAD, and we are interested to find its value. So we will solve this equation to calculate the value of VAD. This minus 4 volt and minus 3 volt will become minus 7 volt. Now place this minus 7 volt on the other hand side of equal to calculate the value of VAD, that will become 7 volt. So the answer of voltage VAD is 7 volt. This was exercise problem number 2.24. Thank you. See you again in next video.